All right, welcome back. My name is Darren Thomas, and I am the Director of Educational Research Techniques. In this video, we're going to keep looking at fraud detection with Python, but we are now going to focus on ensemble methods. So let's go ahead and see what we can learn. Now, when we're talking about ensemble methods, what we're doing here is, instead of using just one algorithm, such as random forest or logistic regression or decision trees, we're going to use them all together. Each model is going to make its prediction, and then there's going to be like a vote where the different models work together to try to make the best prediction of whether a case is fraud or not fraud. And so it's a little bit more of a complicated approach to using machine learning techniques, but it's a very, very powerful way to potentially improve the performance of your model. So let's go ahead and start putting in our various libraries. There's a lot of them, by the way. And so you can see here, the first four are all, let me just put these in an order that's kind of neat and clear for you. The first three are going to be the different algorithms or different models we're going to be using to try to predict fraud versus not fraud. So logistic regression, random forest, and decision tree. The voting classifier, this is the function that's going to combine all those different algorithms that we showed in the previous line there to work together. The rest of these are kind of, you're already familiar with these. Train, test, split is for splitting our data into training and testing. Then we have our metrics here. So confusion matrices, classification report, and the ROC curve. And then we have our grid search, which is going to serve a purpose in a second for using, trying to predict parameters. But we'll have to see if we use that one, I have to be honest with you. And then the last two, of course, is pandas and NumPy. Now let's go ahead and prepare our data. Now, the actual data location is not going to be shown on the screen for privacy reasons on my computer. But we have a data set called DF. I prepared that before the video. And we're taking the 2nd to the 29th, I believe, columns as independent variables. Then we convert these to an array. Then we take the last column. That's going to be our Y data, our dependent variable. That's going to tell us if it's fraud or not fraud in our training data. And we make that its own object and convert it to an NumPy array. And then down here, we create 4 objects. A training test for our independent variables and a training test for our dependent variable. And we're setting our test size to 30%. That means 30% of our data is for testing, 70% is for training. And then right here, we're just setting our seed here. So let's go ahead and run these 2 lines in case I forgot. All right. Now, we're going to do something even complicated as well for the model development. All right, so we have our 3 classifiers right here. And what we're doing here is that we are making an instance of each of our classifiers, and we're setting some of the parameters. So right here, we have logistic regression. We set our weights here. So the class weights are not balanced. So a penalty is 15 times. In other words, if you get something wrong in terms of it's actually fraud, but you did it. Often the weights are not balanced when you're dealing with fraud detection because you're looking for anomalies. The max iteration is set to 1,000. You can look up what that means on your own time. And we even set the seed for that one. Then we have our random forest classifier. Again, we set our class weights right here, the criterion right here. There's different types, entropy, Gini, etc. The max depth, again, we've talked about what these different parameters mean in prior videos. So how deep the tree will go. The number of features is set by the log. Minimum number of samples in a leaf, number of estimators, all these have been explained prior. And then lastly, we have our decision tree. So we set the seed, and for this one, we have a balance weight for our decision tree. So those are our 3 classifiers. And so we go ahead and set up an instance of that. And now what we're going to do here is we start to get to work in that now we used our voting classifier ensemble function basically. And what we're doing here is LR stands for logistic regression. And so we're pulling that from classifier number 1. RF stands for random forest, and we're pulling classifier number 2. This is kind of like I think a list here. DT stands for decision tree, and that's coming from our 3rd classifier. Oh, excuse me. And our voting is hard. Now there are 2 types of voting. Hard means each classifier that you're using gets 1 vote, and that's it. So if 2 say fraud and 1 says not fraud, it's going to be classified as fraud. And so there's no softness to it. We'll learn about soft voting in a second. Next, we fit our data. This is normal, using our ensemble model that we just made in the prior line. And then, of course, we predict. So we go ahead and run that. And there's no probabilities here. We'll explain that more later. And now we're going to assess our model. How well did it do? And so you can see right there for yourself. So the precision was 89. The recall is 0.86 or 86%. F-score is 87%. You can see, of course, the accuracy is always very high because, outliers. So you can see we're not really struggling too much with anything. We have some false negatives and some false positives. That's to be expected. Now, how bad or good this is depends on the context of the study. Also, comparison of this model to other models, etc. But those are our overall values right now. Now what we're going to do is we're going to make some modifications to our model. That's our next step. And so let's go ahead and take a look at that. All right. So now we're still using our voting classifier function here. Our estimators are still here. They're all the same. This time the voting is soft. Soft voting has to do with using probabilities rather than just whether it's fraud or not fraud. So it takes into account something that's a little more nuanced. That's why it's called soft. We're also modifying our weights. So what we're doing now is that for our random forest model, it has 4 times the influence on the actual results, almost like it gets 4 votes versus the other 2, if you will. And then flattened transform has to do with how the data is shared. It's a way to adjust how it presents itself. It's kind of complicated how to explain that. I would recommend you look at the documentation on that. So let's go ahead and run this. And then we're going to, of course, fit our data and predict. All right. There we go. Again, there's nothing to see just yet. And then, of course, we have to do the assessment the second time with our modified model. All right. So you can see here that we've made some progress on precision here. That went up a little bit. Recall is about the same, I believe, as from last time. So it looks like our false negatives have gone down, which may be why the precision went up. But our false positives went down. I'm sorry, false positives went down. False negatives stayed about the same. And so again, this is what you do. Now, one note, remember you're not supposed to use your testing data twice. That's a no-no. But this video is for demonstration purposes only to show you how to do this. You want to run iterations on your training data, which is why you can do some cross-validation, which is a great way to explore this without testing it on your data. But that was outside the scope of this video. So why don't we go back? We're going to review what we looked at and then conclude this video. So what we did here was we took a different approach to fraud detection in that we were using an ensemble method to detect fraud. And so with ensemble methods, you're using more than one algorithm to predict whether or not an instance is fraud or not fraud. And so, of course, you prepare your data. That's normal. What was unique here is that you have to set up instances of each algorithm you want to use. And so in our case, we use 3. One note I need to mention is that it's probably wise to use an odd number of algorithms, especially when you're doing when the voting is hard, because otherwise, if there's a tie, well, now what do? So, and then of course, we created an instance of our Ensemble model right here, Ensemble underscore model. We fit our data, we make our predictions, and then we got our output. And so you can see we had a little bit of an issue here with false positives. That's why the precision was a little bit lower. We went back, we ran the model again. We gave more weight to the random forest model here. We did a flatten transform, which again, you can look that up in the documentation. And when we ran things again, you can clearly see that our precision went up, whereas looks like our recall stayed the same. So again, whether that's good or bad depends on the situation. So I want to thank you again for watching and listening to this particular video. My name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you again for watching, and you take care.